Hi, I'm Daniel. I am going to be applying to MD-PhD programs next cycle, and I wanted to make this video partially to just help me clarify my own thoughts as I think about the process, and hopefully to help someone out there. I'm not sure how applicable this will be to a ton of people, but even if it helps one person, I think that will be worth it. And I just wanted to share this and have this as a nice record for my future self as well. In this video, I'm really going to be talking about why I want to do an MD-PhD. I have a series of slides that I'll talk through, so I'll occasionally be looking at my laptop. Let's get into it. The short version of this story is that I've always been interested in deep philosophical questions about the nature of reality and human flourishing. And that has I think that can lead some people to be tempted to think, oh, that's just too snobby. Daniel, like, what are you doing? That's kind of a lot. However, this is genuinely accurate. I've always been really captivated by these philosophical questions that people have wrestled with for millennia, really. I also fell in love with science by studying animals, especially insects and marine mammals. So I'm not just interested in the abstract things, but also the very detailed things that are in our external world, especially animals. I also learned that I wanted to be a physician by shadowing doctors, chatting with different physicians in different fields, and working in the medical device industry. Ultimately, I decided that I wanted to become a physician scientist and pursue MD-PhD training by being exposed to incredible physician scientists, especially a prolific academic neurosurgeon and philosopher of the mind. That is the summary of what I'm going to be talking about, and I'll get into more detail right now. Quickly, it's worth shining some light on what an MD-PhD program really is. So an MD-PhD program is an typically 8-year program that can be 7 to 9 years, but typically 8-year program that combines the Doctor of Medicine with the Doctor of Philosophy. It's a program where you enter with the prerequisites for your MD and then the PhD program that you choose to do. And you leave the program as a fully trained physician and a fully trained scientist. If you do want to be a clinical, like a practicing attending physician, you do need to also finish residency and or fellowship. After you do that, then you are fully well-trained physician scientist. And it's not just a doctor who does research or a researcher who meets with patients sometimes. It's really a unique thing where you take some of the coolest aspects of both careers and you combine it into a unique thing as opposed to just trying to scramble to do a little bit of science and a little bit of clinical work. So it's a really unique career and it's a really unique, long, rigorous training path. But for the right person, it is really fantastic. I wanted to give a shout out to this web app I made. It's totally free, so I'm not selling anything on it. It's called usmedschoolmap.onrender.com. So if you're considering doing an MD-PhD, it might be worth it for you to look at this resource I made, because I made it to help myself and the other people in my situation who want to, for example, look at a map of all US MD-PhD programs, get some more info on them. It's really, honestly, good. I think I'm proud of it. The format of the rest of this video is really going to be an outline of my academic and career journey. And I think ultimately everything aligns and nicely converges on the physician scientist path. I should say before I continue, to become a physician scientist, someone doesn't necessarily need both an MD and a PhD. However, it's a really good and in a lot of ways the straightest path to becoming a physician scientist. So it's a really good way of equipping someone to do that. In terms of my origins in the academic and professional world, as early as in middle school, whereas most of my friends were really concerned about sports or fashion, which is totally normal for middle schoolers, what really bothered me were some of the deeper questions about ultimate reality. Things like Does God exist? What is real? How do I know the things that I think I know? And these existential questions really motivated me to pursue philosophical investigation. So, as you may know, philosophy is a domain of inquiry that's very old, like one of the really oldest academic fields. And it's divided into several branches which cover a lot of these ultimate questions. So, there's things like metaphysics, which is the study of fundamental reality. There's epistemology, which is the study of truth, knowledge, and justification. There's also ethics, the study of right living and duties. There's logic, which is the study of rational thinking and symbolic reasoning. And then I like to think of a fifth category. So we have those four, and then the fifth category being philosophy of X, where you can substitute X for anything. You can do philosophy of mathematics, philosophy of science, philosophy of religion. And ultimately, these constitute philosophy. And if you want to ask questions like, does God exist? Or what makes something true? Philosophy is really where you can try to parse out answers to those questions. So as early as in middle school, I was really captivated by these questions. And I didn't want to just ask the question and then be like, oh, that's interesting, and then move on. I really wanted to see what other people have thought about these questions. At the same time, though, I loved learning about small details. Things like, how do insects see things? How can water bears survive living in space? How can we see subatomic particles? And what is a quark? Things like that. So this curiosity really early on in my life encompassed both the big ultimate questions and also smaller questions about everyday things that I encountered. Not that I encountered quarks in everyday life, but more so looking at small rocks and thinking about its constituents and thinking about subatomic particles was really, really interesting to me. These interests motivated me to pursue science and philosophy, specifically biology and philosophy. That way I could think about animals and other organisms and also ask the big questions. My first school where I explored these things was a community college in Washington State called Green River College. I fell in love with physics and further fell in love with philosophy through some of the courses I took at this school. To illustrate a little bit, one of the things that I really found interesting in physics was this idea of electromagnetic waves, where you have, as in this picture, you have your electric wave, and then you have, or rather you have your electric field, and then perpendicular to that you have your magnetic field. And the fact that these are so synchronized and perpendicular, it's so strange to me, but so cool. And I remember thinking like, wow, even though I can't see these electric fields or these magnetic fields, they're all around me all the time. I really liked that. I like that mathematics can describe not only electromagnetic fields, but pretty much everything in the physical world. That's crazy. The fact that math corresponds to the world in any way is actually a really interesting philosophical puzzle. And the fact that it is just so cool. So I really, really enjoyed physics. Initially, I thought it was really hard, and I didn't know if I could continue doing it, but I ultimately pushed through it, and I'm really glad I did. I took a philosophy of science course in this college as well, and it was taught by a really good philosopher. We got to ask questions like, what is science? What separates science from non-science? How do you go about falsifying a theory? And what is the distinction between a hypothesis, a theory, and a law? Interestingly, these aren't scientific questions, even though they sound like them. They're really second-order questions about science, and I was really captivated by these questions. We used this textbook, a historical anthology of philosophy of science, that I really loved. I still have it to this day. This school also strengthened my passion for lifelong learning. I really early in life learned that if I'm not constantly learning, I get really bored. And not only that, like a experience of not learning, but I have such a positive experience when I do learn something new. Whether it's something completely different and totally out of my comfort zone, or getting deeper into something that I've always been or recently been interested in. I continued studying biology and philosophy at my next school, which was Western Washington University in Bellingham, Washington. I love Western. It is a super cool school. It's up there way in the Pacific Northwest, and it's really pretty. It does rain a lot, and it's like a different vibe than what I was used to, but I really liked my experience. I have a different video talking about it. One of the biggest things and one of my biggest positive takeaways from this school was that it's such a good place to explore nature. This is a picture of Oyster Dome, which is my favorite hike in Bellingham. It's not a super crazy hike, but at the end, the payoff is so worth it because you get to be on a cliff and overlook this forest, and then the water. Like, this is a literally real picture of the summit of this, and it's just so awesome. I loved this hike. I did it several times, and I like this picture because it illustrates how this area in Washington is such a good place to get outside and explore nature. The biology bachelor's that I did was focused on ecology, evolution, and organismal biology, and this was such a great place to do that because the ecological landscape in this area is so rich, and there's so much to explore with environmental science, with the organisms around there. So focusing on animals and plants like I did was really cool. Particularly, I really loved a marine mammal biology class that I took. And this isn't my picture, but it illustrates what kinds of things we got to do, because not only did we study marine mammals like orcas in class, but we actually got to go out on the boats that our school owned and go whale watching for class. Like, that's crazy. And I really liked it because being out on the ocean with all these other students who like learning about animals, who love marine mammal biology, it's so immersive, and our professor really loved it as well. He did his PhD in Mexico, where he actually studied dolphins. So he was swimming with dolphins for his research a lot. That's so awesome. And I was infected by his enthusiasm. It was such a good experience. Also, I fell in love with insects through my courses here at Western. Before this school, I actually was pretty indifferent to insects. I didn't think much of them. I wasn't scared of them. I didn't hate them. But I also didn't love them at all. I was more like, oh, okay, yeah. Occasionally I would have spurts of interest in them, for sure. For example, in kindergarten, I had a book all about scorpions that I actually liked a lot. And I remember thinking, oh, this is cool. So I did have spurts of interest for sure. But it was really until I took a class where we had a professor who had studied insects for decades, really most of his life. And he had spent 10 years working on a book all about how to identify insects. That was really cool. And it was really, again, infectious to be around someone who loves the subject so much. We actually had to collect insects as part of this course. We created our own natural history collection where we would pin insects, we would preserve them, we would add all the scientific data to make it scientifically useful. That was such a cool process. I loved it. And this picture is especially cool to me because this is a swallowtail butterfly, and I remember sitting by a bush for literally like 20 minutes waiting for a butterfly to fly low enough for me to catch it, because this bush was super tall. It was probably like 15 feet at least tall, and this butterfly that looks exactly like this was always flying near the top. So I waited. I was just sitting patiently. Once it got low enough, I actually took a swipe with my net and I caught it. Such a memorable experience. I'll never forget that. Being outside like this, being surrounded by organisms, whether it's whales or insects, really continued to make me passionate about nature and biology. My interest in the big questions didn't go away though. I'm glad that I not only studied biology, but I also studied philosophy at Western. And Western has an unusually good philosophy undergraduate program. The faculty there are very strong in metaphysics, epistemology, philosophy of religion, ethics. So there's a lot of really good work that you can do there. The courses are strong. And I had really good mentors to walk me through thinking about what does it mean to live a good life. So for example, I took a class on the 7 deadly sins. That was really, really cool. And we got to talk about all of them. For me, I gave a presentation on envy, which I thought was really interesting, and it helped me think about envy in my own life and in other people's lives. I also got to ask questions about how the universe began, how did life begin, and what is truth itself. I took several epistemology courses where I ended up at the end of it agreeing with the consensus view in epistemology that the best theory of truth is one called the correspondence theory of truth. This theory says that a proposition, which is basically a declarative statement about reality. So for example, if I ask someone, oh, did you close the window? And then they say, oh, that's true, that's false. That would be weird because a question isn't a declarative statement, but something like all men are mortal. That's a declarative statement, so we call those propositions. So the correspondence theory of truth says that any proposition is true if it corresponds to the way the world actually is. It sounds really trivial and basic, but it actually has really important implications for how we think about knowledge and reality. So I think the correspondence theory works. I think it's true. I think it definitely corresponds to the way the world is. Thinking through those questions and having good mentors to help me through those were really valuable to me. By the end of my time at Western, I was debating between going the philosophy route and doing a PhD in philosophy, or going the science route and going to grad school for more biology stuff. And I ultimately decided to do more grad school focusing on biology, specifically insects. So I enrolled in a graduate program all about insects, which is called entomology. That's the subdiscipline of zoology where you study insects and other arthropod relatives like crustaceans, arachnids, so spiders, and then millipedes, centipedes, things like that. The school that I enrolled there was called Washington State University. Go Cougs! In Pullman, Washington. I had a really good time there for the time that I was there. And I specifically focused on agricultural entomology, studying an insect pest of wheat. During this time, we took a graduate level an insect taxonomy course where we had to collect 100 families, I think it was 120 actually, families of insects. That's actually a lot harder than it sounds. So it might sound like you just go out, you grab 120 insects, you're good. But it's actually more complicated than that. There are 1 million species of insects, and there are some families that have lots of different species in them. By family, I mean the kingdom, phylum, class, order, family, genus, species hierarchy. So you need to collect insects enough at that hierarchy, the family level of that hierarchy. And there's a family of beetles, for example, called Carabidae, the ground beetles. And there's 40,000 species just in that family. So theoretically, you could catch 40,000 different species of insects and only have one family. So catching 120 families is a lot harder than it sounds. And I really worked hard on that collection. I had so much fun doing it too. And working on that really cemented my interest in science. And it made me want to be a scientist. And the reason for that is because science is really all about going outside and seeing how the world actually is. As good as philosophy is, because I love philosophy, there are things that you can only study by going out and looking at the way the world actually is, as opposed to thinking about how you think an orderly world would be. So science, since it's empirical or observation based, It's all about going out, observing things, and seeing how things actually work. And part of that is in the biological world, you go out, you identify different organisms, you are getting dirty in the mud or in the creek, and you're just looking for stuff. And that's part of the scientific enterprise. Specifically, a highlight that I want to share is all about that curiosity element, where you have to be innately curious to go out and look at things and learn about the way the world is. Unlike engineering, which seeks to apply what we know, science is all about having that innate curiosity to explore the world through observation and valuing knowledge for its own sake as an intrinsic good. Even if it isn't applicable to something necessarily, it has intrinsic good to help us understand the world around us. And that whole attitude cemented my interest in becoming a scientist in some way or form. There were challenges during this time and some pivots, so due to several health and financial difficulties, I withdrew from my grad program to seek full-time employment. I had worked a lot of different part-time jobs. I'd even done a full-time summer job twice, doing a summer camp for kids who'd been through different trauma like homelessness, abuse, neglect. That was a really, really good experience. However, I did need to go ahead and get my first full-time real job, quote unquote, as in like a full, like salaried with benefits job. And my first real job was at 23andMe. This was before 23andMe recently went bankrupt. And I started working there a few years ago. I really, really loved this job. I was doing medical device regulatory affairs at 23andMe. So that consisted in playing a key role in bringing their medical devices to the market. Regulatory affairs is all about making sure that medical devices comply with domestic and international regulations. In the US, the domestic regulations are set by the United States government for sure, and also the Food and Drug Administration is the one who really evaluates the compliance of devices to laws and regulations. I learned so much about that whole world through this job because before this, I didn't have any experience in regulatory affairs or medical devices more generally. So this was a really good learning experience. And I got to work on health reports focused on genes like BRCA1 and 2, which are genes that play a role in people developing breast cancer, and then SOCO1B1, which is a gene that plays a role in someone's genetic predisposition to being able to digest, metabolize, and use different drugs for heart disease. Both of those projects were really interesting to me, and it was such a good convergence of science, technology, health. Makes sense because 23andMe is a biotech company. At that time, and still now, a lot of people think of 23andMe as just giving ancestry reports, which are really cool. But I think in my opinion, what really made 23andMe amazing was the use of health reports to be able to give people FDA cleared reports that are legit medical devices. They're software medical devices, unlike an MRI, which is a hardware medical device, but still has to go through the same approval process. That was really fascinating. I loved that. While at 23andMe, I had my first exposure to the MD-PhD as well. Our vice president of genomic health had earned an MD-PhD, and I remember thinking that this had to be a fake thing. There was no way someone had earned both an MD and a PhD. Either degree is a monumental achievement and a huge amount of work. So to be able to earn both, I was thinking there's no way that this person actually did it at a legit school or something. But then I was like, wait, they did. I did more research and I was blown away because I had never heard of an MD PhD. And I learned that our vice president, yes, had spent 8 years doing her medical degree and also getting her PhD and really becoming a legit physician scientist I was shocked, and I remember thinking, this is crazy. Like, how would someone do this? Why would someone want to do that? And I started learning more about the physician scientist path, the career, the MD-PhD training path, and I was very, very interested. I remember it's starting to simmer a lot in the back of my mind, and it continued for several years. While working in the medical device space there, I did some data analysis for my job, and I really enjoyed the data analysis that I did. I also got to work with full-time data scientists there who spent their whole time just doing data work. They had done their PhDs in computer science from really good schools. Being surrounded by them was really motivating and really interesting. And that made me want to learn more about data analysis and coding. I initially started by taking Harvard's free online course, CS50. It's a really, really good course, and my first recommendation to anyone considering learning how to code, because it really gives you a nice survey of a lot of things, a surprising amount of things for a one semester introductory computer science course. It'll give you the basics of data structures, algorithms, and then a number of different programming languages like Python, C, SQL, which is really its own thing really for database things. It also gives you the introduction to markup languages like HTML. So you really get to do some fun stuff. I really like the really initial project, Project Zero, where you create something in Scratch. It's a nice visual interface for doing programming. I loved my Scratch project because I made it in 5 hours, like less than a day. And it's a Godzilla game. I have a video about it. That was literally my first foray into these things. And I remember thinking, this is so cool. Granted, that wasn't my first ever exposure to coding. My first ever exposure to coding was in a biometrics course at Western where I did R to analyze different data sets. And I remember thinking R was actually really interesting, but I didn't pick it up again until CS50. After CS50, I was like, okay, I think I want to do this more actually. So I decided to enroll in Western Governors University. Most of my videos center around my BS in computer science there. And I'm really glad I did it. I finished it, and I've made a video all about my full experience there, if you want to check it out. So there's a few reasons I chose WGU. One, I was working full-time and at 23andMe, so I didn't really want to do any other full-time in-person obligation. I didn't want to stop working to just do computer science for fun. So I knew I needed an online school, and I knew I needed something regionally accredited. I was not going to enroll in a trash school that's not regionally accredited. I found out that WGU is, when I was considering it, is accredited by the Northwest Commission on Colleges and Universities, which is actually the same accreditation body that accredited my alma mater, or my initial alma mater, School 2, which was Western Washington University. That made me have tons of trust in WGU, so I decided to enroll. And it was a really good experience. I've talked about it a lot, for sure. And I learned a ton about coding. And at this time, I was full-time at 23andMe and full-time at WGU. Really busy, but had a lot of fun with both. My next school, I didn't enroll in it as a student, but I did something else. I did something called a Research Experiences for Undergraduates. This is a program funded by the National Science Foundation where you get to do a summer project. You're basically a full-time researcher for a summer, and you live at and work at the school that you go to. You don't necessarily have to take courses. I specifically did this because I wanted computational research experience. I had done some research in biology, but I really wanted to do more computational stuff, and here I got to do that. I enrolled in Texas State University's RU program in their Department of Computer Science. And this was a really good experience. I was very, very busy, so I worked full-time at Texas State University. I was a full-time student at WGU still, and I was so blessed that my boss agreed to let me temporarily go part-time at 23andMe so I could do this. My argument was that by doing the RU program, I would be better equipped to help our team at 23andMe, and everyone agreed with that, which was really cool. I also took a graduate course in data science for the summer I was at Texas State University, so I was super busy, but I had a lot of fun doing all those things. Unfortunately, during that time, I was let go from 23andMe as part of a company-wide layoff event. So I was doing my RU, and I wasn't laid off because I was doing the RU thing. I actually was laid off because 23andMe let go of about a third of the company, including a lot of people on my own team. It wasn't performance-based, or at least that's what they told us. What they told us was it was really just based on minimizing the team as much as possible and keeping only the most essential people. Since then, they've had a lot more layoffs, unfortunately. So all that to say, though, I had been laid off. They gave us a severance. I was debating what to do with my severance. I could have continued where I was doing things like continuing in medical devices, or I could do something else. And since I'm not that old, I was like, well, I've always wanted to do more philosophy. I think that would be cool. The opportunity has arisen for that if I would like to do that. So I was like, oh, well, while I still could, it would be nice to go do more philosophy. So I decided to go ahead and do that. So after I finished the RU at Texas State, I was continuing WGU, but I decided to actually go to another school and study philosophy. So I moved to California to study philosophy of science and philosophy of religion at Biola University, which is a really good school for philosophy at the master's level. It's a Christian school, so someone who is a Christian who's interested in philosophy will really benefit from going there. Since I'm Christian, I decided to go in and do that, and really glad that I did that. It was a very busy time because I was dual enrolled at both WGU and Biola, and I was also working. So I began teaching biology, and I also resumed working in medical device regulatory affairs. So my second real job was as an adjunct professor of biology. I got to teach university students molecular biology and organismal biology, and I really fell in love with teaching. I had done some teaching at Washington State University. Here I got to really hone those skills more and get a lot better at it. I also got to get better at organismal biology lab techniques and molecular biology lab techniques, which I'm constantly learning now in my position, which I'll talk about later. And I love mentorship and teaching. I've really, really fell in love with those things. Simultaneously, I was working in the medical device industry, this time not at 23andMe, but at a dental device company. This company makes orthodontic resins, a lot of the tools that your dentist uses, different things for scraping or anything having to do with your teeth. This company makes that. So I was helping them get their new, specifically orthodontic resins approved by the FDA. That was a good experience. During this time, I was strongly considering doing more computer science and becoming a software engineer. As much as I like medical devices, I had been thinking it would be nice to do something that uses my computational skills a little bit more and that pays more. So I was definitely considering software engineering. And I actually was grateful to earn acceptance into UT Austin's MSCSO, the Master of Science in Computer Science online program, which I've made a video about. I was weighing a few options because I have all these interests, and I was thinking, okay, should I go this route? What should I do? By this time, I also was not loving everything about my role at my dental device company. And I was thinking, wow, what should I do next? Because I can do a number of things. Should I do this? Should I do that? I'm so grateful that I got a lot of clarity by attending a conference, which I'll talk about now. I attended a philosophy of science conference, which actually attracted a broad range of experts in science, in the medical world, who are practicing physicians, and philosophers who are interested in the intersection of science and philosophy in a number of different topics. And really, this was actually the most life-changing event that I've ever had in terms of my career. Not necessarily in terms of my, personal spirituality or beliefs or anything, but in terms of my career, this was the most life-changing event for me because I was just so immersed in this vibrant intellectual culture of people who do research, who ask these big questions, who are interested in multidisciplinarity. And the single most important talk that I got to experience and be a part of was this talk that an academic neurosurgeon gave on brain surgery, free will, and the philosophy of mind. I was enthralled, truly enthralled, and inspired by this talk because I had had all these different interests and I had been thinking about a lot of different things. I had been experiencing some self-doubt about my interest in the MD-PhD that I first learned at 23andMe. I just thought it was so hard and it's so much effort. I didn't know a ton of doctors, so it seemed so out of reach. But I was interested in it. I was also interested in all these other things, philosophy, software engineering, all these things. And I think this talk and this conference gave me so much direction because I, for the first time, felt that all my interests could converge in a really interesting way. And I could do something like this academic neurosurgeon was doing. I was super interested in the research he was doing and the clinical work he was doing as someone who's performing brain surgeries, who also gets to incorporate philosophy of mind and a lot of these big questions that focus on human flourishing. So I was like, wow, this would be awesome. Like, wow, I think if I can live like this person in the future, that would be really, really cool. At the conference and afterwards, I chatted with multiple MD-PhD students who are pursuing this training, and I reflected a lot on my own interests, my own abilities. I got to talk with and shadow physicians, most notably a gastroenterologist, who I'm so grateful that I know, a really, really renowned gastroenterologist. When I shadowed him, I was just really impressed by the craftsmanship that he has and other physicians have in this field. And before this, I didn't have gastroenterology on my radar at all, but afterwards I was very interested. I'm very interested now. It's in my top 3 specialty interests as of today. So that was just such a good experience. For all these reasons, I decided to go ahead and pursue MD-PhD training and the goal of becoming a physician scientist. I also decided to say no to MSCSL. I made the hard decision not to pursue this excellent online master's degree in computer science because for a number of reasons, I've made a video about it, but the short version is I have this new direction where it makes sense. It actually tracks with my own past interests, so it's not like super new thing, but I think it's a really good natural next step. And I won't really have the time that I would need to do really well in the UT Austin program. It's super rigorous, takes a ton of time, which is totally fine. I'm not scared of that. More so, I think I am working on other things right now that I need to be putting in a lot of time and working hard for. So I decided not to pursue that. And I chose not to pursue work as a software engineer. Even though I like software engineering, I make my own projects and web apps a lot. Doing that full time is not as fulfilling to me as being in the scientific world where I use my computational skills to do scientific work. I can still create apps that help science and medicine, and also working with patients, being able to be a part of the clinical world and meet the needs of people in health disparities. Love that. So the theme, as I've made this decision, is convergence. Convergence being that all my interests converge on the physician scientist path. My love of physics, animals, computer science, and molecular biology all focus on becoming a scientist. And on the other hand, all my passions for medicine and the work of a physician. And medical devices streamline towards the physician path. And importantly, my passion for multidisciplinary thinking, asking big questions to enhance human flourishing, and teaching align with my interest in science and medicine towards the physician-scientist path. Being a physician-scientist isn't just trying to scramble to be an okay physician and an okay scientist. It's really a unique thing that combines aspects of both into a very particular career. I like this outline from the University of Pennsylvania's MSTP MD-PhD program. Theirs is one of the largest MD-PhD programs, and it breaks down the path really well, where you have these different years, year 1, year 2, all the way to year 8, where you're doing a mix of your graduate school, your clinical work, and at the end, you really become this chimera. I love how they describe it, and Dr. Brass, the director there, describes this idea of a chimeric approach to being a physician scientist, where you combine aspects of clinical work, aspects of research world into a unique thing, a hybrid, a chimera like this MD PhD chimera here, and also a lifelong learner where you're constantly learning. You have to do that to do a good job as a physician scientist. And that just tracks so well with my constant interest in learning more about the world around me. And it has really been a nice next step what I'm doing right now, because my real job that I'm doing now is working as a post-baccalaureate fellow at the National Institutes of Health, specifically the Eunice Kennedy Shriver National Institute of Child Health and Human Development. I am loving it so far. I am doing a lot of molecular biology work and also bioinformatics work. So I get to use my computational skills, also my biology skills, in a really cool path. And it's really, really good, invaluable preparation for MD PhD, because not only do I get to do really good wet and dry lab work and research, I also get to shadow the physicians here, world-class physicians here at NIH, and then world-class research facilities here as well. So it's really, really good preparation. I think it's a great launching pad for MD PhD. My next goal is one where I actually don't know yet what school it will be. I'll be applying to at least 30 MD PhD programs, and I will happily go to any of the really good programs that I will be applying to, and we'll see. I'm excited to see where I end up for that training. Thanks so much for watching. If you've watched this far, wow, yeah, I hope you've gotten something valuable from this video. If you have any questions either about my specific path or any aspects of my path, happy to give clarification, happy to help motivate or encourage, or also just share some other thoughts depending on what you're interested in. And I hope you have a great rest of your day. Thanks.